Hey, Abby, just a couple of things on test five I wanted to go over with you before I grade your test. Starting with problem number four, standard deviation problem. You did everything right except your calculator messed you up here. If you have negative 15 squared, you have to remember when you put that in a calculator, you have to put it in parentheses. So like this, parentheses, negative 15, close parentheses, and then squared. You should get a positive 225. So yours gave you a negative 225. Remember, when you square a negative, you'll always get a positive number. So if you go back and change that there, your process was absolutely correct. You did everything correct on that, except for your negatives. When you squared them, you ended up with negatives. So if you go back and change that, you'll be great. Number five, you did well on. Number six. So this is one I know you'd struggle, and I tried to help you through email, but it's tough to try to type this out. So this is the empirical rule. It always takes the exact same shape and characteristics. So we're going to just say that we have a data set that has a mean of 40 and a standard deviation of 7. So we start out with our bell curve. We're going to draw the bell curve. The center of the bell curve should be 40, which is, that's just our mean. And you did that. You did the mean at the center of your bell curve as well. You did just fine with that. But now then, we should only go out 3 steps on each side. So going to the right of the mean, we go 1, 2, 3. And each step, we add the standard deviation. So 40 plus 7 is 47. 47 plus 7 is 54, plus another 7 is 61. And that's it. We only go 3 steps. Then we go 3 steps the other direction, going to the left. 1, 2, 3. And here at each step, we subtract the standard deviation of 7. So 40 minus 7 is 33. 33 minus another 7 is 26. 26 minus another 7 is 19. So that's what your bell curve should look like for part A, is just 3 steps on each side of the mean. Then for part B, it asks a question similar to this. Obviously, I've changed the numbers here from the test. But it asks, I'm going to paraphrase here, what percent is between 26 and 54 would be the equivalent for my numbers. Well, for me, here's 26 and here's 54. That is 2 steps to the left and 2 steps to the right. And that empirical rule tells us that if you go 2 steps on each side of the mean, we expect 95.5% of the data to be in that range. So this is 95.5%. For part C then, it asks something like what percent falls between 19 and 61. So here's 19 and here's 61. That is 1, 2, 3 steps to the left, 1, 2, 3 steps to the right. So the empirical rule also tells us if you go 3 steps on each side of the mean, we expect 99.7% of the data to be there. So this is 99.7%. Oops. And then it asks us, part D would be something like what percent is between, actually I switched up part D and C here. Part D was the 60, I'm going to move this down here. Part D was the 19, between 19 and 61. So that should have been the 99.7%. Part C would have been the equivalent for part C would have been asking what percent is between 33 and 47. So if I go up here, here's 33, here's 47. That's just 1 step on either side of the mean. The empirical rule tells us if you go only 1 step to each side of the mean, we expect 68.3% to be in that range. So this would be 68.3%. And then finally, part E asks us what percent would be more than 40. Well, 40 is the mean. It's right in the middle here. Since this is symmetrical, we expect half the data to be larger, so 50% would be larger than the mean. So this answer would simply be 50%. So like I said, I changed the mean and standard deviation. So the numbers that actually appear here will be different for you, but the percents will still apply. They'll still be the exact same percents. The percents never change, just these numbers at the bottom of the curve. So then next for number 7, finding mean, median, and standard deviation for a table. So I'm going to use a different table here so that you can go back and redo this. So my table, we're going to have number of siblings. So we're going to take a sample of people and we're going to ask them how many siblings they have. So we might have 0, 1, 2, 3, or 4. And we're going to say that nobody had more than 4 siblings in our sample. So our frequency, let's say we had 7 that had 0 siblings, 34 with 1 sibling, 18 with 2, 9 with 3, and 2 that had 4 siblings. To find the mean, well, what we have to do here for the mean is we're going to take the value. So this is going to be x. This is the frequency of x, or f of x. We take the value, x, times its frequency. So 0 times 7 is 0. 1 times 34 is 34. 2 times 18 is 36. 3 times 9 is 27. 4 times 2 is 8. Next, we're going to find a total of this. If we add that all up, 0 plus 34 plus 36 plus 27 plus 8, we get 105. We also have to find the total frequency here. If we add all those up, 7 plus 34 plus 18 plus 9 plus 2, we get 70. So the mean is then found by taking this total, 105, divided by this total, 70. So for my data set, this will be slightly different than yours. I get a mean of 1.5. To find the median, there are 70 items in this list. So I do 0.5 times 70 equals 35. So it's telling me my median is between the 35th and 36th number in the set. Well, which one's the 35th and 36th? Well, the first 7 are zeros. If I were listing them out, that would be 7 zeros. The next 34 are ones. Well, 7 plus 34 would be 41. So that means the ones go all the way up to the 41st number. Well, we want the 35th and 36th. So both the 35th and 36th number have to be ones. So the median is just a 1. Finally, we want to find the standard deviation. The standard deviation is going to be a little trickier. It follows basically the same steps as what we did for the standard deviation in problem 4. Now that we have the mean, we subtract the mean. But remember, we have to subtract the mean from the original number, from x. So up here, when we subtract the mean, we're going back to this number, 0. So the mean was 1.5 here. Your mean will be a little bit different. So 0 minus 1.5 gives us a negative 1.5. Here we're using the 1. 1 minus 1.5 is 0.5, negative 0.5. Then the 2. 2 minus 1.5 is positive 0.5. The 3. 3 minus 1.5 is 1.5. And the 4. 4 minus 1.5 is 2.5. And then just like with the regular standard deviation, we're going to square it. Negative 1.5. Now remember here is same. A negative squared has to be positive. So negative 1.5 times negative 1.5 is 2.25. Negative 0.5 squared, or negative 0.5 times negative 0.5 is 0.25. Positive 0.5 squared is also 0.25. Positive 1.5 squared is also 2.25. And 2.5 squared is 6.25. And then we have to do times the frequency. So here we have 7 times 2.25. Let's get the calculator out for that. Give us 15.75. For 0.25, it's 34 times 0.25. Give us 8.5. I'm going to do 8.50 just so my decimals lines up. 18 times 0.25. It's actually going to be 4.50. I'll double check that. It is. And then 2.25 times its frequency of 9 is 20.25. So that was this times the 9. 20.25. And finally, 6.25 times 2. Well, that's just going to be 12.5. So now I have to add all of those up. So I'm going to add those. I'm going to do the calculator just to make it easier. 15.75 plus 8.5 plus 4.5 plus 20.25 plus 12.5. And I'm getting 61.5 is that total. Now I divide that by, now the frequency is 70. I'm going to divide by 70 minus 1. So in other words, I'm dividing by 69. So 61.5 divided by 69 gives us 0.8913. Then we have to take the square root of that. So the square root of 0.8913, we have 0.9441. That is the standard deviation for my set. Again, yours will be slightly different because you have a little bit different data set. You actually only have 1 through 2, 3, 4 instead of 0, 1, 2, 3, 4 in your data set. Problem number 8, you did perfectly. So we'll leave that one alone. We'll jump to problem number 9. So using a contingency table. So I'm going to do a contingency table for high school students that take AP classes or who do not take AP classes and tracking where they go. So we're taking a sample of students. We're going to track students who go to four-year college, students who go to a tech college, and students who go through no college. And let's say that for our numbers here, we have 38 that went to a four-year college that took AP classes and 51 that did not take AP classes that still went on to a four-year college. 26 of those who took AP classes went to a tech college. 53 that went to a tech college that did not take any AP classes. And then we had 11 that took AP classes that did not go on to college, and 21 that did not take AP classes that also did not go on to college. Now remember, we want to find our totals here. So if I add up my row totals here, if I add these up, I have 89 here. The tech college adds up to 79. No college adds up to 32. My column totals. Let's see, my AP adds up to 75 who took AP. No AP adds up to 125. Adding in both directions, I get a grand total here of 200 students total. So if I have a randomly selected student, out of those 200, let's say, what is the probability that they are going to no college? Well, we have 32 that are not going to college. That's the total for the no college rule, out of 200. So I could leave it as 32 out of 200, or I could divide it out to get 0.16. I might have, what's the probability they took no AP classes? So if I come back up here, I'm going to do some erasing here. No AP classes. There were 125 that took no AP classes. That's the total of the no AP column, out of 200. So it's 125 out of 200. If I divide that out, I get a 0.625 probability. What's the probability that they took AP classes and went to a tech college? So and means they did both. So if I come up here, AP classes are these. Tech college is these. The only ones who did both are these 26 students there, still out of the 200. So that's 26 out of 200. I divide that down, I get 0.013 is that probability. What is the probability that it was either no AP classes or went to a four-year college? Let's see if we get that. So no AP or four-year college. So here's the no AP classes here. Here's the four-year college. We want to add these numbers. Now, we don't want the totals. We want those numbers in there. So we got 38, 51, 53, and 21. And that's still going to be out of 200 because the grand total is still the 200. So if I add those all up, what do I get? 104, 142, 163 out of 200. If I divide that down, I get 0.815 probability. E. We're asking, what is the probability that they went to no college given that they took AP classes? So what this is doing, the same when we say given, we're narrowing down the population. We're only looking at those students who took AP classes. We're not looking at the whole group anymore. So we're only looking at these here who took AP classes. So only these 75 students. Of those, 11 didn't go to college. So there's 11 out of 75 that did not go to college. So if we divide that down, I'm going to use the calculator. We get 0.1467 probability. And then finally, the last one, F. What is the probability that they took no AP classes given that they went to a four-year college. So again, we're narrowing down the population. We're not looking at all 200 students anymore. This time, we're only looking at those who went on to a four-year college, these 89 students. Of those 89, we want to know how many did not take AP classes. So we have 51 out of those 89 who did not take AP classes. So 51 out of 89, I'll divide that out. Give me 0.5730. So again, obviously you have a different contingency table with different categories and different numbers, but the process of calculating is the exact same. So hopefully this helps you out a little bit. Let me know if you have any questions. I will not grade the exam that you sent me until I hear back from you and you can redo these problems.